I guess let's just get started. And I suck at this thing. Just yeah, just a disclaimer. I'm not someone who like really knows how to do this stuff. I'm a complete beginner in this. So yeah, this is going to take some time. Anyway, so let's just get started. So this is maximum sub array. Okay, so given an integer nums, find the sub array with the largest sum and return its sum. Okay, so for example, if this is your array, find the largest sum, the sub array with the largest sum. So this sub array has the largest sum, sure, and return its sum. Okay, I think I get it. So what are the constraints? Yes, so the nums dot length thing is 10 power 5. Nums, whatever they actually are, I don't care about that, as long as they fit in the size that we want. Sure. So this is classic DP, I guess. So then for a particular sub array, let's say like from some index A to B or I to J, whatever its sum is yeah. So okay, in fact you don't even have to do this thing. You can just figure out the sum for the array starting at 0 all the way till some index I. You can do that, and then to find the sum of the array starting from I to J, you just have to do Sj minus Si, right? True. So, or Si minus 1, but yeah. So that gives us like an order 1 computation for the sums. Sure. Then what we want to do is find the largest sum and return its value. So there are going to be like n square of these, and you can just keep on just going through them, and that is probably enough. Like, yeah, I guess because there are like negative numbers and positive numbers as well, so this is going to be messed up if I just yeah, true. And that's why it's 10 power 5, I guess. Okay, wait, it's 10 power 5. That's actually still a big number. So if I, yeah, that's a problem. That is a problem. Okay. What can happen? What are the properties that I could use? First is it should be the largest sum, right? So it must end with negative numbers, right? So it's like negative 3, and yeah, so like 4 has to be included, negative 1 may not be included, something like that. So it is always going to be between two negative numbers, right? So your largest number, so largest array thing, it should not have negative numbers on its edges. It must have positive numbers. So it's definitely going to start with positive numbers. You can exclude all the negative ones. That's one pruning thing. Okay, that's still not really helpful. Think about it. You know, that's going to be smaller at that point. Okay. Apart from the order n square, I don't think there's any other way to do it, is there? No, doesn't seem like it. Like n square of these guys. Not nice, not nice. Come on, think about it. You don't want an n square algorithm. You want something smaller. So what can you do? So okay, that won't work. Let's say I was just thinking about all the different you know, yeah, so all the different sums, so arrays which start with a particular index, right? So which one of them would be the biggest? Since it's going to be like Sj minus Si, whichever one has the biggest Sj would be the biggest, right? So for every I, you just figure out which of these j's is the one having the biggest sum. Sure. Oh, okay, I see. That's pretty interesting. And then you subtract off Si, right? And so that gives you the answer for I, and so on. So if you can get that in order 1, you will have an order n algorithm. Now how do I do that? One thing is just to maybe sort these sums, and at the same time also the indices associated with them. So like I'll know which one is the biggest straight up, and then I also know the index. Okay, cool. Huh. So if it's like, okay, okay, cool. Sure, we can sort it up just like that. Okay, wait, so you can sort all of these sums without any context of this ij thing, right? Fine. And what we want is just a difference of two sums associated with some indices such that the first index, the one you subtract, right, the sum of which you subtract, is less than the other one. Cool. And you want the biggest such possible. Starting to make sense, huh? Sure. So if I just yeah, if I just do that in like some particular order, so ascending order in terms of the sums, fine, and then I keep iterating that. So it's like, okay, the biggest sum and then whichever one is cool, then that would actually give me the thing. So I just have to keep iterating. Sure. Let's still order n square. That's not good at all. Okay. Yeah, that's still order n square. It's definitely not the good algorithm. And I don't want to sort these things. That's probably not a good idea. Isn't there a way to just like get the biggest but not having any of these guys beforehand? Get the biggest without having any of these guys before. Oh, a min heap or a max heap, sorry. Okay, this is messed up, but you can use it. So let's think about it. Like so you have all these. So first I'm just gonna actually make the sum array, right? So I don't like it as, so L equal to nums and n equal to the length of L, whatever. So this is going to be a min heap, and I don't know how to implement a min heap in Python. I don't like this, but I need that order one thing, right? Or order log n at least. Sure. Huh. It is a min heap. I know what I'm doing. It's just I don't want to code this because a heap data structure in Python is a problematic thing. Isn't there some library which does that for me? Yeah, it probably is there, right? There must be a library that I can use. So Python heap library heap queue. I think I have seen this before. Fine. This module provides implementation of the heap queue algorithm, also known as a priority queue, whatever, blah blah blah. Fine. So given an array, just apply heapify, and it makes a heap. Sure. Then heap queue dot heap push and heap pop. So this pushes the value onto the heap, maintaining the heap invariant, and this is, so this just does min heap or what? Use the list initialized to, okay, you can transform a populated list into a heap via function heapify. Fine, the following functions are provided. So the heap is just a list. Fine. Push the value item onto the heap, maintaining the heap. Okay, I get it. So just heap queue dot. Am I allowed to use this? That's the question. Merge multiple sorted inputs into a single sorted output. Okay. Dot n largest, dot n smallest, whatever. Basic example. I assume this is allowed. I have no idea if it is, but hey. Okay, n smallest elements, I don't want that, just want to do the heap pop, I guess. So it removes the smallest, so this is a min heap that it's maintaining. So it's heap q, so I'm just going to import that. Okay, so I will be like, cool, import heap q. Am I allowed to import that? I'm not so sure about, but whatever. So let's just get to it. So n is the length, whatever. I just want to have the sum, so initially it will just be 0. Actually, let's put s, so s equal to 0. So for, and we'll just put s equal to, I don't know, 0 times n for now. Okay, cool. Yeah, sure. I mean, this is okay, this is fine. So for I comma x in enumerate in this list, what I want to do is just keep getting the sum. So it's like s plus equal to whatever x thing is, and then just add this to this. So it's like not capital S, small s, and then s I. So I initially is 0, that's why. So that's gonna be equal to small s. This creates the sum array that I want. Okay, now comes the hard part, the heap thing. So we want a min heap, and so yeah, so that's going to be like, find the minimum thing to subtract off. Sure. So I just call this thing as heap. So it's initially going to be nothing. It just has 0, right? So you also want the best. So I'll be like, we don't want to return the array, we just want the sum, right? So best will be like, so what if it's just the first element? So it's like s sub 0. So it's capital S, by the way. Right. So okay, now it's going to be for I comma s in enumerate. No, I don't need this, I just need the s. So, or whatever, so enumerate s, right? So in all the sums, sure, you'll just keep appending this. So it's like heap q dot it's called heap push, I think. So heap push your new sum that you have put. Okay, but before that, so what I'll do is first I'll just pop something off, right? So it already has 0 because nothing, so that is also there. So you know what the sum is, subtract from that the minimum. So min s I don't know, that's just equal to heap q dot pop. So heap q dot heap pop, I don't know if I'm writing the syntax correctly. So for whatever is in the heap, it's gonna pop that off, the minimum one, that is. Sure. Is this the best data structure or not? Hey, all I really want is the minimum, right? Yes, I guess. And I can reuse that. Cool. I can reuse the minimum. If all I want is the minimum, why have a heap? You don't need a heap. A heap is when you have to extract minimum a bunch of times. But now you just have to extract it one time. So I don't need this. I don't need a heap. All I have to do is just maintain the minimum, right? Okay, that was weird. So the best is this thing. Right, we'll start with the minimum s. The minimum sum is just going to be like whatever s0 is, right? And this is going to be working out fine. Okay, so this is going to be the, yeah, okay, so we'll actually, for I in range, I guess I know what I'm doing. I told you I'm a bit slow. I don't like, it's not like I'm gonna click with it right away. Okay, so we'll start off at 1, right? Okay, process the 4. first one to it, right? So it will be like S is just equal to S sub I. Okay, subtracted off, so it's like candidate is just whatever this sum is minus whatever the previous best was, so the minimum was, so min S, subtracted off. Now if this thing is better, so if candidate is better than your best, then this is your best. So or you could just write that whole thing as a maximum thing. So it's like your best is just the maximum of your candidate and the best. Cool, fine, that's amazing. Then after that you also want to have the minimum updated, so your min S, that's going to be the minimum from your the new sum, and obviously min S, right? So you keep updating your minimum sum and also the candidate. Cool, this looks fine, this looks fine. And then what? So once that's done, you will have your best, right? So like when it runs for n minus 1, it does the same thing. Min as we don't care about at that point, we just care about the best. So now we'll just return best. This looks okay, I guess. Yeah, because in the end, for whatever Sj you have, you just want to have the minimum Si. Sure, subtract it off, and that gives you the best thing. Cool. And so even if you like go ahead, your min S is just like, you can just keep updating it, and that works out. Cool. So what's the complexity of this thing? It's order n. It's order n. Now let's try to run this and see what errors I have. First, actually, let's just see errors right away. So L is the nums, n is the length, fine. S is 0 initially, then right. This is fine. This is just an initialization. If I was in C, I would just initialize it like that. So for I, X, and enumerate, S is increment, sure, fine. S of I equal to fine. So that's okay. The sum value is cool. Hey, so what happens if I don't have anything inside? Is that possible though? So it's got to be 1 at least. Cool. In that case, best would just be this thing. Min S is just going to be that, and for I in 1 to n, so that's not going to run, and then just return the best. That's okay. It's equal to S of I, equal to. So what about the empty subarray? Can that be a possibility? Interesting. Is the empty subarray allowed? It might be, because so yeah, sure. So best is either S0 or it's 0, so it's whatever is the maximum. So why 0? Because like when there's nothing, that's 0. Cool. That's fine. This seems okay. So let's just run this, and let's hope this works out. Cool. And I'm pretty sure I'm gonna get some sort of error right away, but it's the first try. Expected. So you have nums. Oh wait, what? Why would you expect -1 when you could just, what the hell? No, that doesn't make any sense. Why would you have -1 when you could have 0? Unless subarray has to be at least, okay, then it would make sense. So don't have this in that case. Don't include the empty array thing. Right. So then this would in fact be the best. Sure. This is messed up. Like, I definitely don't want to be using it in a real setting. And now this is giving me a wrong answer. What the hell? Okay. Must be at least one thing over there. So okay, actually let's control z that thing. So this does find me the best. So if it's like all negative stuff, it's just gonna give me nothing. Sure. Right. Yeah. So if it's 0, if the best that you have gotten is 0, what does that imply? That implies that almost everything is negative. So you'll just choose whichever is the, because if it was even a single positive element, it wouldn't actually give me that. True. True, true, true. So in that case, what's going to happen? You won't actually have anything outside. So okay, if best is 0, right, then what happens? In that case, you just pick up the largest one and then return that. So return maximum of your not sums, maximum of L, right? And let's try to run that. And this is messed up. I don't know why you want that kind of logic, but okay, somehow this is really bad. So I don't beat anyone. This sucks. Alright, just move on, move on. It's not about how good of an algorithm I wrote, it's like whether or not it made sense to do it. Next question. So this is spiral matrix. I don't know what this thing is. Given an m cross n matrix, return all the elements of the matrix in the spiral order. What is the spiral order? So you got 1 to 2 to 3 to whatever. This is the input. This is your matrix. Okay, the output is 1 2 3 why is that a 6? Oh, because okay, so when you say spiral, you just mean like and so on. Sure. So this is just what a very simple rearrangement of the whole thing. I mean, why even have an algorithm to do this thing? It's just so stupid, isn't it? But hey, let's do it. So we'll have A as the matrix. So A is the matrix. Rows is the number of rows. So that's going to be like the length of this matrix. Columns, that's going to be like the length of A0. So what happens if there's no row at all? In that case, hey, so is that possible? So no, they have to be 1 at least, right? Well, it is an m cross n matrix, so let's just call it m and n, whatever. Fine. Okay, now what I want to do is start and then just keep doing this spiral order thing. So what exactly happens when you have a spiral order? You start and then you're like, okay, this is really messed up, isn't it? When do you move? Pretty much. You could have a very complicated visited array thing, or you could just use math, and I'm gonna do the other one. So what's gonna happen is, first, if it's like out of bounds, if it's going, then you have to change it, obviously. But then what is out of bounds is also gonna change, right? So let's say you have done this, so now it has gone to this. Cool. Right? And so then you jump inside. Oh, okay, I think I get it. So for example, consider this. You go for the outer boundary completely. So it's like 1 2 3 4 5 whatever. You do this thing and then you jump inside. So your boundaries actually change, right? So your starting I, starting j change by 1 comma 1. Sure. Yeah, even if you had a bigger sort of a matrix, the same would happen. Every time you eat up the outside boundary, it changes by 1 cell. Cool. What happens if the matrix is too small? Like there's no, yes, if it's like a single row or if it's a single column. In that case, you just, yeah, right. So cool. So okay, not even a single row or single column. If it's like a 2 cross, yeah. if the number of rows is 2 or the number of columns is 2, then that's a special case. Then all you have to do is just, sure, that makes sense. Okay, your m and n will just become one less basically every time you eat up the boundary. In fact, not one less, but rather two less. Your I will increment. No, it will be in fact one less because true. So your ranges will be different. Okay, so how do I do it? So we'll just have like row start, which I'll just call RS. So RS is going to be, so initially it will just be 0, row end, that will be M, so it's just one bigger than the included element. Right, so this is number of rows, so row ends at M, column start, that's going to be 0, column end, that's going to be N, right. Now I'm just going to set up a while loop. So while row start, or row end minus row start, while this thing is bigger than 2, so if it's equal to 2, it's a weird scenario, and what column end minus column start is bigger than 2, will do something. So first you need to have a list, right. So I'm not gonna do the whole what do we call it, create the array and then keep putting, so maintain a counter. I'm just gonna keep appending stuff inside of it just to make it better. Fine. So while row end minus row start is bigger than 2 and column end minus column start is bigger than 2, right, so every time I eat up, it's one less. Cool. So you're gonna start off at the first one, so it's okay. For I in range, so it's like 4 things, right? So the first path, okay, so first horizontal, this is top basically. So for I in range, your I does not actually change, so you'll just have a fixed I. So it's like your I is your row start basically. Then you just have for J in range, so your column start all the way till column end, right. We're just gonna append stuff, so L dot append whatever your arrays ij thing is, ij, just append that, sure, column start to column end, perfect. Then we'll go for the right column, so here your I will change, your j will just be column end minus 1, right. So for I in range, so it increases basically, so it starts off at row start all the way to row end. We're just gonna do the thing, so L dot append a sub then you'll do the bottom. Remember, we are going in a clockwise fashion, so now your I is fixed, so I is just row end minus 1, right. So now for J in range, you start off at column end minus 1 and you go till column start inclusive in the reverse order. Why is it taking so long? I don't know. This is a stupid question, it shouldn't take so long. So that's bottom. Next thing to do is obviously just up, so left thing. And if after this like nothing works out, we'll just do it again. So yeah, so it's like j is column start for I in range, so it's gonna go back. So it's like starts at row end -1 all the way till row start -1 L dot append. Yeah, so that does it. That gives you a way to eat up these boundaries. Then what? Then you'll just have the row start incremented. So right, okay, so this is the for loops are done. So now the row start, that will be incremented by 1, your column start will be incremented by 1, your row end, because you have eaten up that whole thing, so it's going to be minus equal to 1, column end is equal to 1. So this by the way goes down by 2 all the time. Sure. So now what happens if this is actually less than or equal to 2, right? Okay, so assume that, yeah, so if so first what could happen is it eats up, it's like it's 1, right? So if it's 3, this difference comes down to 1. If it's 2, well, it doesn't work. So if it's 4, it comes down to 2. So eventually it will be 2 or 1. So if you know if both are 2 and 1, that's kind of a messed up scenario, but whatever. But yeah, so here's the thing. If it's 2, so if row start minus, so row end minus row start is equal to 2, right? And what happens? So you just have 2 rows, sure. So then it doesn't matter like what sort of columns you have, whatever your number of columns might be. So you'll just start from like column start to column end, you'll just have everything. So just do the top and bottom thing at this point. You don't need to do anything else. Sure. And then the bottom. Oh, okay, I remember something. Okay, this is a problematic thing. There's one big problem with this. I'm double counting. Yep. That's kind of a problem, isn't it? So I'm double counting, so I don't want to be doing that. So over here, when I'll do right, and when I'll do, I don't know, right and let's say left, so I don't want to be double counting, so I'll actually start with row start +1 and till row end -1 only. And similarly, when I'm doing the left thing, I want to start with -2 and yeah, so the row start -1, it's slightly above, I don't want to do that, so just row start. Cool, that's probably a good idea, right? Yeah, it doesn't double count then. Cool. Okay, so just 2 rows, then you do this thing, top, bottom. Fine. If it's a 1 row, then you just do a top, this is gonna take some time. So if your this thing is just 1, what happens if your row end is the same thing as your row start? Well, that can't happen. That's just not gonna happen because it decrements, right, eventually. Yeah, even if it's like m and n are just 1, in that case your row end would be 1 and your row start would be 0. So sorry, yeah, so then it would be 1 in that case. So if this happens, then just do the top thing. So sure. Okay, otherwise, so something could happen with columns. So what if your column end minus column start, so none of these things happen and you have enough rows, but what's going to happen is, like, let's say your columns are just 2, so it's just 2. In that case, yeah, you just want to do the top sure, then the right, then once again bottom. Hey, that's, oh, so you don't actually have to have the columns over here apparently. What if a single one? So let's not put it as bigger than 2, let's put it as bigger than 1. Right. Interesting. So even if you have like 2 columns and a bunch of rows, you can still do the same thing. You can do the top, then the right, then the bottom, and then the left. Makes sense. Sure. So the other thing would be if it's 1, if your column end is the same thing as your console, in the inclusive sense. In that case, you just have to do like the whole thing just like that. So your j is fixed, so your j is just whatever is the column start, and then for I in range your row start or little row end, just gonna do n dot append, so ij, sure. Okay. So here's one thing, if your rows are 2 and your number of columns is 1, all these edge cases though. Think about it. Number of rows is 2. What if, okay, so if you have just 1 column, you're good to go. What if you have 0 columns? Could that happen? Sure, you can. In that case, column start to column end, it's just not gonna do anything. So you won't actually have any appendations, which is fine, which is completely fine. So no problem with that. Like let's say you have a 2 column thing and then you just run it, and so now suddenly there's no columns, there's 0 columns, and then this is what will happen, right? Your number of rows is still big. You do this thing. It's only when there's like 1 column that you have to be worried, because if it's 0 columns, you're probably like already exhausted it, so it doesn't really matter. It's either row 2 or row 1, and yeah, okay, this is fine. And this should apparently do the thing, right? Yes. So now I'm just gonna return the thing. So return, or first let's just print, actually, just like let's print it at a bunch of different things. So first, after this while loop, we are gonna print whatever your list was, then you'll print it, and then you return the thing. So return L. Let's try to run it on some test cases, and probably this will just be these test cases. That is amazing. It just happened, I guess. Okay. So I want to give it a test case of my own, so it will just be, so let's say just 1. All right, and let's run this thing. It somehow worked out for that as well. Why isn't this messed up? But okay, so let's not print it and let's just submit it now. I wasn't expecting it to just work like that, but well, it worked out, so whatever. I don't know what magic happened, but it somehow is working out. Sure, I guess. And since I'm kind of free, let's just do yet another problem. Just cause, Okay, once again, wait, what? Oh, it's a different thing. So you are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Okay, sure. Okay, so you are at some index, and then you can jump to like 2 steps further. Okay, return to if you can reach the last index, or false otherwise. So if you can reach the last index in that, yes, right. So if you are at the last index, you're already done. If yeah, okay, so jump 1 step from 0 to 1. Wait, what? Oh, okay, it's the maximum length of the position. Sure. So you can jump here, here, and so on. I see. Simple dynamic programming, I guess. Yeah, order n square is the worst case for this thing, I guess. Is it? Well, if any of these is going to be like, then you're pretty much done. Sure. So starting from a particular index, when can you reach? You can only reach if you can reach some index where you can reach, basically. Okay, that's getting weird, but you know what I'm saying. It's a dynamic programming thing. So then all you need to know is the first, right? So the smallest index that you have, which enables you to reach the last one. Sure. And so if the first one is that index, and you're pretty much done. Cool. So this is going to be a simple order n thing. So what we'll have is, first we'll just have the last index as the index, because okay, from there you can obviously reach the thing. Then we go down. So like for the one before that, we'll see, okay, from there can you jump to an to this minimum index that you have, and if you can, okay, that's the new minimum index, and so on. Right. So this is going to be easy. Okay, cool. So let's just call this thing as x. So this will be okay. So first, what happens if the length is 1? So if n is 1, firstly, if n is 0, then that's messed up. So but it can't be. So if n is 1, you just return true anyway. So just return true. Like, don't think, just return true. Now I'm assuming there are multiple of these guys. So what happens is just x will be the index. So x is the last index, which will just be the n minus 1. Cool. Right. Sure. Okay, cool. So for I in range, so I'm gonna go back, right? So start off with n minus 1 all the way till 0, right? So x will be the minimum index that you have from which you can reach this. Cool. So if L sub I, right? So L sub I is the number of steps that you can have. So if this thing is bigger or equal to the difference between these, right? Yeah. So if it's like one length jump, then you can jump to the next one. So sure. So we get the difference, which is your current index, your smallest one, obviously, minus the current index, right? In that case, make this a new minimum index. So then you just do x equal to I. Cool. And then you just keep doing that. Right. It actually works out. And then once all of this is done, right, if x is 0, I mean, I just return x equal to 0 basically, Because if x is not 0, this is messed up. Like then you cannot return. Okay, I'm just gonna run this right away. I don't know, maybe I'm not interpreting it correctly. I am. That worked out pretty well. Give me the wrong answer. You didn't give me any wrong answers, so this was easy. So this was a bit too easy, so I'm not satisfied with it at all. So I'm gonna go to something else. Give me something hard. Although I know it's just medium level problems, but still. So the reason I'm doing medium level problems is because like they're doable. You don't need some fancy algorithm to do this thing. And most of the hard ones do require some sort of fancy algorithm or some previous knowledge. I've solved like 50 hard questions, and I know, I struggled through all of them, and for like, I don't know, 10% of them I had to just look up the solution. Like there was no way for me to get the solution just like that. So it becomes like, it goes from like a simple DSA problem to straight up a research problem at that point if you try doing it without knowledge. And I don't have any knowledge, so it will be a research problem for me. It will be like something I'll be stuck on for multiple days. I don't want that. Okay, so let's do this thing. Given an array of intervals where intervals i's start to end, merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So okay, this is doable, I guess. So you have this interval 1, 3, 3 is bigger than 2, so you're gonna include that and so on. So what is this? A stack, a simple stack thing. So you'll just stack up all of these guys and be done with it. So first thing that you'll put in the stack is the empty, then, or you could just put something like, I don't know, -2, -1, just for the sake of, sure. So okay, so this is not going to be that complicated. So you have intervals, so just call these things as I or I list, or let's call it L in fact. So L is the list, so it's intervals. Why do I use L all the time? Because it's easy to write and because I have very less typing speed. Let's call this thing as capital N, so it's just the length of, or let's call it small n, whatever. So N is just the length of this thing, whatever. Okay, so your stack will start. So okay, so if N is 1, that is there's only a single thing. But what happens if N is 0? Okay, it can't be 0. So if N is 1, then you just return the thing itself. Sure, so we just return the thing. So return L, fine. Okay, now I'm assuming there are at least 2 intervals. Okay, so I'll put the first one in my stack. So we'll just have stack, which let's call it as S. So S is this stack, which will actually have L0. Cool. Sure. Okay, now we also need the last one. So last, let's call it as L. L is going to be the last element, which is 1. So 0 in this case, the index one. Sure. So I'm gonna put both of these guys. You can just do a current thing actually. So we'll just have a current is L0. Okay, cool. The stack is just this thing. So for interval, so for I in your L, what happens is, if your starting is less or equal than whatever the thing, so okay, so if you have 1, 4, 5, it still matches up, right? So then whatever your current ending is, right, in that case you just increment it. So like current ending is basically this guy's ending, so it's just I1 and you just move on, right? Yeah, you don't think about it. Else, if it's not less, actually it's not just this. Okay, right, that's a problem. There's a problem with the sorting over here. Suppose we'll actually have to sort this. So I'll just have L equal to sorted. It's not actually run it right away. You do the base case first, then you do this thing. So L equal to sorted L. Why am I doing this, by the way? Because I want it. Because it's gonna be easier that way if I'm sure that it is in a particular format where like your starts are always going to be in an increasing order. This is what it will do in fact. That's how it compares lists. But yeah, so if I know this, in that case I can do a lot of stuff, right? So sure, you just like increment the whole thing, fine. Else, so if your current one is the ending, it's not containing this thing, right? In that case you add it to the stack. So else you just add it to the stack. So s dot append whatever your current interval is, and then your new current interval will be this I thing. Okay, once all of that is done, you still have the current interval, right? So you have to append that. So it will be like s dot append current. So let's just do a mentally dry run on this thing. So let's just think about it. If there's like one interval, we're pretty much done. If there's two intervals, right, let's say it's like 1 3 and 2 6, what's gonna happen? L is just sorted. L just sorts it as 1 3 and then 2 6. Then current is L 0, so it's 1 3. It's checking whether or not you can add more things to it. Stack is empty right now. So for the intervals in L, so first it encounters is obviously just 1 3 itself, and so 1 3 is like cool, your starting is matching, your ending is matching, whatever. So it's like its starting is in fact less than or equal to its ending. So whatever is the bigger ending is the one which it will have. So it's not okay, it's not just I1, it's supposed to be max in fact. So it's max of I1 and curve 1, right? Because it could be like it completely encapsulates that, then that's also possible. So whatever is the biggest, sure. So it does 1 3, fine. Then it does 2 6. So for 2 6, 3 is bigger than that, so it's matching. And yeah, and so it checks, okay, maximum of 6 and 3, that's 6, so that's the current ending, fine, right? So it does that. The else doesn't work, and after that it just appends the thing. So it's like 1 3 2 6, that just becomes 1 6, sure. And then I just want to return this thing, so just return s, and let's just run this thing. Okay, cool. Fine, looks about right. This is still an easy one, give me a hard one. I am not satisfied. So I said that I'm gonna be doing two medium problems, but these are not medium problems, these are easy problems, so not nice. So you're given an array of non-overlapping intervals where intervals I is the start to end, represents the start and end of the ith interval. Okay, intervals are started in ascending order by start, cool. You're also given an interval, new interval, what the hell, that represents the start and end of another interval. Okay, so intervals is a list which has all of these intervals. New interval is another interval. Insert new interval into intervals such that intervals is still sorted in the ascending order by start I. Okay, fine, that's just like simple binary search. What's the big deal about it? And intervals still does not have any overlapping intervals. Okay, so intervals still does not have any overlapping intervals. Oh, okay, so the last problem, whatever I did, fine, you can make a new array and return it. You don't need to. Okay, fine. Wait, just to check. So start and end for each of the intervals, it's going to be okay. I'm a bit confused. Are all so the intervals that I've already given, are they overlapping or not? It doesn't look like they are, but oh, okay. So these are in fact non-overlapping intervals. Fine. In that case, it's very doable. So first, you just need to know where the start thing is, right? Yeah. Okay. Okay. Cool. So okay. So with binary search, you can do that. It has to be after the finish of someone. Sure. So here's how it will be. You'll binary search. Okay. So firstly, it's just non-overlapping intervals, which means that the finish times are also in the ascending order, right? Because these are non-overlapping. Because if they were not, it's kind of messed up. So yeah. Sorry. So you can do binary search based on finish time. So here's what it will do. For the new interval, we'll figure out the interval just before that using binary search. Sure. And then you'll know where to split it up. So you will in fact split it up. You'll add this, and then now you just have to merge this to that. Yeah. So just like keep adding these guys, and you're pretty much done. So this guy's finish time. If this finishes, yeah, okay, cool. If its start time is before the finish time, then you just have it inside, right? Then you just keep updating that. Cool. So you want the biggest start time such that so the finish time is also something that you have to binary search to figure out. Okay, cool. So here's what we want. First, we want the interval just before this new interval that you're going to add, and then you also want the interval that has its start time just before the finish time, right? So you want to do binary search for S in the array of F's, and you want to do the binary search for F in the arrays of S, right? Because that will be the last interval that you're going to join. Cool. So from all of that, you'll just remove it pretty much, and then you will put that inside. Sure. So just binary search. Okay. So I'm going to write binary search first. And this is not simple binary search. This is actually like, because you want to have indices, huh? So it should return the index, not the number itself. Cool. So first we'll just write binary search. This is something I've written a lot. So define binary search. You're given some list. You have a number. I want to return the largest number in L that is before or equal to X, right? So we'll just have n is the length of, so length is already like an attribute, so it doesn't actually compute a lot of it. So stored somewhere. Sure. Well, okay, so isn't length like order n or something? Could be. You know what? I just put the length as well, so that you don't have to worry about this. So you have the length, right? Now you want to do this in log n, obviously. Cool. So for not for, so we'll just have start and end. So S will be the start, that is 0. End will just be n. Okay. So while start is less than end, we keep doing stuff. So we'll just be like middle is start plus end by 2, blah blah blah. If middle, so if L middle is equal to X, just return the thing. So if it just return X, sorry, return m. Cool. If it's not, so elif else if m is less than x, in that case the number that we are searching for, you know that yeah, so it's gonna be like inclusive of m as well, so it shouldn't be n, in fact it should be n minus 1. So this is inclusive. Cool. So we just have end as whatever m is, right, inclusive of m, because it could be that m, so it's in fact the index that we're looking for, it's just less than x. Sure. So elif, it's not even elif, there's only 3 things that could happen. So else, so it's bigger obviously. So if it's bigger, then you know that before m, right, before m and included m, you do not have a number, so you just have start is m plus 1. Sure. All right, this runs. Cool. Now if start is equal to end, right, you reach something like that. In that case there's only one element to check, so and I mean we know what we're doing, right? All of these elements are just only gonna have less value than that, so you know number is confined to that. Sure. Okay, so end if it's less than or equal to x, you're like good to go, and then you'll just return the thing. So return start, otherwise it's kind of messed up, you don't return anything. So sure. So otherwise what's gonna happen is like everything is bigger than x, so you'll just return something. So it's like else return -1 or return none for that matter, in fact, because it's Python, so you can use that. Yeah, okay, cool. If everything's bigger, then there's no number which is just less than x. So that's if start is equal to end. If it's somehow bigger, so it's not less, if it's equal, then it's bigger. What happens when it's bigger? Can it be bigger? It can be bigger. Sure. In that case, you just don't do anything, just return none like that. Yeah, because then you didn't find the thing at all, isn't it? True. That seems like the thing. It seems like the thing, doesn't it? So what should happen is there should be an and then you return this thing. Otherwise, whatever happens, we don't care. We just return none. Fine. That's your binary search. I just hope it's correct. It will be, right? Sure. Let's try to run this thing. So we'll just do a bunch of printing. So let's just put like ls something. So it's like 1 2 3. I don't know, 1 3 4 3. Yeah, it's some sorted array. So just do binary search the list, the element that you want. So let's just say like 3.5. Want to want just less than that, and the number of elements in the list. So I just want to print that. Cool. And okay, I also have to return something, right? So I have to return a list of integers. So I'm just gonna return something, and I know it's gonna be wrong. Obviously we know it's gonna be wrong, but why not? I don't like doing binary search because it's like we require to write code. So okay, so what did it output? It outputted 0. What the hell? No, it's not supposed to be giving me 0. Huh? It's 134 and 3.5, so if it's equal and n of s is less than or equal to x, then you just return this thing. And n is equal to x, then you're just like, okay, return m, number of elements, that's going fine. What could have made this happen? Guessing I'm doing something weird about, yeah, middle one is less than x, so you know that x is after this one. So okay, I messed this up. So it's actually like this thing. Your start should be middle, but here your end will be m plus 1, right? So if your lm is bigger than x, so you know you cannot have that included, so it's going to be m minus 1 in fact. Cool. Fine, let's run this again, I guess. And this is a good problem. This is a good problem. It requires a lot of thinking, I guess. Dude, I hate doing binary search all the time. It's just, wait, what do you mean time limit exceeded? Bro, that can't be. Something isn't going quite right about this. No, I know. This is one way to do it. But then, since what I want is slightly different, I'll just leave S plus E. Sure, that's gonna work out. Cool, so now it's 1 as expected. Let's try something different. Maybe like, let's make everything bigger. So, you know, just put, I don't know, 4, 5, 6. Huh. Oh yeah, it's none as expected. Cool. So now you know how to binary search. Fine. Now let's get back to this thing. What we were doing was, you want to binary search that. So, okay. Let's just intervals. Let's call this thing as L. So L will be the intervals thing. So it's gonna be intervals. S and F are just the new interval. Right. Capital S is all the startings. So it's gonna be like L. It's okay. It's gonna be just I sub 0 for I in L. The finishings. Wait a second though. Wait a second. Doing binary search. You just copied everything. That's not very nice. It's already odd n that you did. Pretty much just copied the whole array. That's not very nice. I don't want to copy the array. Then how do you, isn't there an easy way to do this thing? I don't want to modify the code, unfortunately. नहीं,
मैंने लैपटॉप में से विंडोज उड़ा दिया पूरा। पहले
क्यों?
डुअल बूट था ना थोड़ा थोड़ा।
अच्छा,
अभी मैंने डिस्पेस जब उड़ा रहा था तब मैंने गलती से बायोएस उड़ा दिया, तो बूटिंग का कोई ऑप्शन ही नहीं था, तो जॉन का पेन ड्राइव लगा के उबुंटू 24 डाल दिया फिर।
I see, I see.
पूरा स्क्रैच से नया ओएस लीड कोड। ये अच्छी इन्वेस्टमेंट है बेटे, सही इन्वेस्टमेंट करते हो।
Instead of the list, let's just have functions. Yeah, this is actually better. So instead of lists, let's have functions. This assumes that you basically have an arithmetic function and then you want to find the, yeah, that's better, that's way better. So here you can just put some function in. Cool. So else is the your bunch of intervals, your function. So sure, so what we want is, let's just say I is the binary search. First we'll just have the function, which will be a lambda function. So it's like lambda whatever index you'll put. So let's say ind, it just outputs your L index 0 thing. Cool. That's your function. Then you also have the what, the x that you require. So first you're using the n, so n is just the length of this thing, so it's length of L. Cool. The x that you really need is just the finish, and then you require the start. So wait, no, the length. So that's I. This code.
Recording?
Yep. This one's gonna be 1. Next, some stupid like intervals question. Geez, once again, you just binary search, you get the thing. Just the one, like, so in your finishes, the one which has, yeah, okay, so wait a second, so your starting is supposed to be, sure, okay, I kind of messed this up. So this is I and that one is J, sorry for that. Right, so this is the one just before your starting, and this is the one, right, the one that finishes just before starting, and this is the one that it starts just before it finishes. Sure. So you wanna include I inside your interval. Cool. And then no, you wanna include J inside your interval. So it's basically like, yeah, true. Because that one does not have it. So from J plus 1, it's the usual thing, and till I, in fact, I inclusive, it's this thing. Right. So what happens if your finished thing is actually equal? That is a messed up scenario, but I guess. Okay, let's think about it. So if, okay, so I'm gonna do this like this thing. So L is just everything, or you could just have left, we call it like left. So left is L, and everything like till I plus 1, so inclusive of L. Now if L sub I, so by the way these are all just pointers, so you are just doing it in place. So if L sub I, let's not do it like that. Okay, so you're gonna do that. Next you wanna insert this, so whatever is J just starts before this guy's finish, right? So if it starts exactly the finish, you're good to go. If it starts before it's starting, in fact, then should you actually involve it? You probably shouldn't. Probably shouldn't. Huh. It is supposed to start after that, isn't it? Nothing much about the finish time. And the other one actually starts after that. Cool. So you just have this other interval. So let's call this thing as I2. Let's call it S1, S2. S1, S2 is just L sub I, so L sub G. Fine. Right. So now what I want to happen is, if it is, so if S1, so if S basically is less than, yeah, right. So when can I include it? The only way that I can probably include it is, think about it. Okay, let's do it like this. Let's do it this thing. So if, yeah, so if L sub I, it's finish. So if L sub I1, that's equal to the starting, right? That just somehow happens. In that case, your starting will actually go back to whatever this thing is. So you just have starting is equal to L sub I 0, right? Else you just add this inside. So else like left or append L sub I, sure, because then it's like not overlapping. Cool. So this was just the starting, right? Yeah. So you just binary search the, yeah, the finish time that is just before the starting, right? Right. So if it's equal to the starting itself, then you do this thing. Otherwise, you're like good to go. Whatever, we don't care. So now you have got everything that's left of this interval, and you have modified the interval accordingly. Now for the right one, so what you did was you searched for the finish time in the starting thing. So you have the interval that starts just before the finish, right? So if this somehow doesn't overlap, right? So you know that everything after that is something that you can actually involve, right? Because it starts before the finish. So what that implies is like the next interval actually starts after the finish. So you can have right is, so basically like L from j plus 1 to everything, sure. Now for LJ though, because it, yeah, so it's starting and finishing we got. Now if it like overlaps with it, that is if so first could happen is like if it finishes before it even starts. So if f2 is less than the starting, so if it's less than s, then you don't really do anything, you don't have to modify it.
सॉफ्टवेयर टूल्स के नेक्स्ट असाइनमेंट करने के लिए
अभी
मैं जा रहा हूँ, तुम भी आ जाना अगर इच्छा हो तो। वहाँ से सीधा सीडीएस सेशन में
sorry, so I just have some interruptions. Anyway, so if f2 is less than s, which means that you're finishing is before the starting of the other one, in that case you just open, so you just skip the whole thing, you don't care about it. So I don't know, pass. Okay, else, so elif, what could happen? So what could happen is your finish is after the starting, sure. So if you're like starting itself, so if s2 is less than, so okay, that's not gonna happen. The finish has to be before the, or at least equal to the starting, because that's just the way you did it, right?
the starting is less, is it? This binary search thing is messed up, isn't it? If thing is, this thing is less than your finish, so then you just include the thing, so your finish will just be like the maximum of f and what of f2 obviously. Okay, so it would be just equal. Even if it's equal, it's okay. Cool. And it cannot be more than that. Cool. Sure, this is okay. What happens if this is starting before that and then you cannot join it? Could it be that it starts and then it finishes like that? Sure, that is a possibility. Think about it. When does it overlap? So firstly, your f2 should not be less than s. So f2 has to be bigger than or equal to s, obviously. So this is the condition. If f2 is bigger than or equal to s, right? And also it should not start after that. So like s2 is less than or equal to f, because if it's bigger than f, then it's kind of a messed up scenario. In that case, it is going to intersect, right? Yeah. Yeah, sure. Then you know how to intersect it, which is just f is the maximum of these guys, and then f is the minimum. Okay, cool. No need for this thing. This looks cool. So now you have included this one somehow, right? If that doesn't happen, in that case you're just like this from J plus 1, right? Okay. Can it be? But okay, this is gonna happen by default, in fact. So the very way that you searched it up. J was when you searched f in s thing, right? Yeah. Okay, what happens otherwise? Otherwise, you know, like, okay, your finish is before the starting of this thing, after the starting of this thing, sorry, and right, whatever is to the right of it is already included. So now all you have to do is just return this thing. So return left plus you include this thing. So you know s comma f. So right. Let's just try to run this. indentation error. 986. What? Oh, okay. There's nothing else over there. What's the problem? This indices must be integers, not non-type. If oh wait, it's giving me none. That's messed up. Huh. So okay, what happens if it says like it just doesn't make any sense, right? Like you do not have it. Choose binary search. So if you start, just happens. It does not have anything before it, right? All of them are actually finishing after that, after you are starting, right? Okay. Think about it. How could it be? I don't want to deal with these cases. Okay, I'll just do them manually, in fact. Cool. So, interval. So if n is 0, there's nothing, then just like return SF. Cool. Okay, cool. So now if f is less than if it's starting, after that just return just find out the one that is gonna end just before. Okay, it's gonna start just before this guy. Sure. From SG. Sorry. like keep including things, and then eventually you find yes, one which, right, so just before you finish it starts, and obviously your starting is way before everything else, so in that case you just include everything. So your, yeah, cool. So right will just be like everything included, not included in this thing, so g plus 1 plus, or yeah, that means the next one is going to be about that. Cool. You may or may not include this one. Let's call this name f2. So f2 will just be L sub j1. So I feel like if this is like bigger, then you just do that. So f is just a maximum of f comma f2, and then so you have this whole list f right, and yeah, the first one, sure. So you're gonna do turning. So now you don't have the none problem going on. Let's run that. It's still not working. So it's 2,5. Integers or slices, not none types. Okay. Why is it giving me none types? Doesn't make any sense, does it? So here's what we'll do. We're just gonna print this thing. So print I comma j. Let's see what it gives. Right. So your I is none, isn't it? So why is your I none? I is basically like, you search for your start in the finish array, right? So 2, which means the one just before, okay, it's not there. So your start is, oh, I see. If it just somehow happens that nothing finishes, that's a problem. Okay, so if it's less than the finish, basically, right? Less than the finish time of the first one, which means that you can just have that thing. Okay, cool. So f is just this thing. We could have s as well. So s is just the maximum of, sorry, the minimum of, the starting, and obviously L0 0. Sure, because it may or may not be included. Let's run that again. J is not defined. Oh, I really wonder, like, if I'm gonna run this in a proper environment, it won't work out, because yeah, thought so. Wrong answer. Okay, so it's getting there, but it's still doing something weird. So it 310, and my output is 410. Why did it do that? New intervals. So I'm not updating the s thing, apparently, it seems. In which case is it? So, okay, so 0. Sure. Let's see. So it did all of that. It got ij. Fine. Left is l till I, so it's l till 0. So it's basically not there. If li1, so if l0 finish, so that's 2. That's equal to s. I'm also gonna print s. Shit, it's supposed to be ij. It's gonna be I, J, S, and F. Let's print all of it. Cool. So ij is 0, 3, and this is 4, 8. Fine, 4, 8, and let's print it. So our left is L sub L till I, so that's nothing. Fine. If L sub I is 0, 1, if it's equal to S, it's not equal to S, it doesn't do anything. Okay, doesn't do anything else. Left dot append L sub I. So it appended your 1, 2 basically, which is fine. What was your I again? Yeah, your I was like you search for start in the finish array. So 4 in the, yeah, so 2 finishes just before it. Fine. And this one does not. Cool. So 3, 5 is not there yet. Okay. Your J is 3, so it's 0, 1, 2, 3. Huh. J is binary search. The start. No, wait, the finish, which is 8. This is messed up. So, oh, it should happen 3, isn't it? I see. Oh shit. Okay, so it should have been I plus 1. Reasoning being that makes more sense. Yeah. It makes more sense because I is like its finish is before the start, or if not equal to the start. Okay, wait. This is fine. It does that, sure. So okay. Fine, so it does that. It appends it. Then you also have to check for Li plus 1, right? Because yeah, because that guy's finishes after the start, right? Okay, so but what if its start is after the finish? Well, that's kind of messed up. So whatever. So we'll choose like s2 comma f2. It's gonna be equal to Li plus 1. Right, now if like your s2 is, if it's bigger than f, then that's messed up, like nothing really happens. So then it has to be like less than or equal to, because yeah, so if this is less than or equal to the finish, and your yeah, and remember that your f that you have, it's necessarily bigger than s, right? Yeah. Okay, fine. So s2 is less than or equal to f. Then all you do is like s equal to minimum of s comma s2, f equal to maximum of s comma s2, f comma f2, sorry. Cool. So that's another overlap that you have taken care of. Let's run this. Okay, cool. If I submit it now, I'm pretty sure something is gonna like break up. Something is not going to be correct. See, I thought so. I'll support it type for non-type and integer. So the interval is just 1. It's just 1, 5. Sure. So this happened during the j plus 1 thing, right? When could this happen? Think about it. What's the standard output? Must have done something, right? It didn't actually do anything. Fine, so it did lj plus 1, that's right. C. So the finished one, which is 3, it checks whether or not your finish has, so one of these guys starting before it. No one actually starts before it, so obviously it's gonna give a none, right? So if it's none, what that means, okay, so so your starting is before the finish, but then nothing actually starts before your finish. Which means it just, yeah, you just have to change the first interval and you're done, right? Wait, but how could this be? How could nothing start before you finish? Because I'm so stupid. This is how it should be, right? Let's use this test case and run it again. Come on. List index out of range. Fine. I see. It's my assumption that something is going to be, yeah. So here all of this only gonna work if like I plus 1 actually exists. So if I plus 1 is less than n, do all of this. Otherwise there's like no point in doing any of it. So sure, use the test case and just run this again. Fine, submit it again. Okay, fine. So this was my log and algorithm, and it worked out. And I guess this is it. I'm gonna be stopping for a while now. Alright, so see you guys in the next video. Bye.